Hey guys, what's going on? Mr. Myers is here. Yeah, my students told me I say that a lot. But hey, you're watching my videos, so that's what I say. So anyway, hey, I want to talk to you today about the p-value. What really is the p-value? Like, how do we explain what the p-value is in context? Because, it might come up in an AP exam or in a college course sometimes. So this is like my last in this series of one prop Z test videos. So if you watched my first few videos, I've talked about how do we find these, how do we do the entire hypothesis test. So I'm going to use the same problem from those previous hypothesis tests. So what you're going to see on the screen right now is my entire hypothesis test. But if you watch those first videos, you should be familiar with these guys, okay? But I'm going to focus all my attention in this video just on what is the p-value. Like, what does it tell us? What are we trying to do with that probability? So let's take a look at this, okay? Okay, oh, there we go. Okay, so I'm gonna slide down here a little bit. So my example was that we took a random sample of 1,000 residents in Mission, Texas, and we did a study. 38.5% of them were overweight, and we were comparing it to the national average at 35.7%. So here's what's going on, guys, with a hypothesis test. My assumption is that the null hypothesis is true. In my entire problem, my entire test, I'm assuming the null hypothesis is true, and I'm going to go and I'm going to try to provide evidence that the alternative is really the true statement, all right? So throughout, we're going to say, you know what would happen if my 1,000 residents really mirrored or looked like what I would expect it to be of the national average at 35.7%. So that's why my null hypothesis was p equals 0.357, and my alternative was greater than 0.357. We found our n, p, and nq. Then we did our mechanics, we showed our z-score, we found our probability, we found that the p-value was 0.0322, and that was less than our alpha level of 0.05, so we rejected the null hypothesis. Now, whenever we reject the null, that's evidence of the alternative. So let me explain why that is evidence. That's the focus of this video, is why is the p-value evidence of the alternative being true, given that it's less than our alpha level. So here's what's happening, guys. What we're doing is we're assuming that the null hypothesis is true throughout our hypothesis test. So this probability that we get here, this z-score, we're really finding the probability. If I did this normal model here, we're finding the probability 1.85 that z is greater than this. What does that mean? Well, what we're doing is we're finding the probability that a sample compared to our null hypothesis would happen just by random sampling. So what is the probability that we would end up getting 38.5%, which is what we got in our sample? What is the probability of getting that sample if the null hypothesis was true? Okay, so granted the null hypothesis is occurring, what's the probability of actually getting in 1,000 people 38.5% of them being overweight? That's the p-value. What's the probability? In fact, what we ended up calculating in this problem was that there is a 3% chance, only a 3% chance of us seeing a sample like we saw if the null hypothesis was actually true. That's pretty small, meaning, like, look, if we did this 100 times, all right? If we took 1,000 samples of people, 100,000 samples, all right? We did this 100 times. We would only see samples like what I got. We would only see this happen 3 out of 100 times. That's pretty rare. In fact, that level of rarity that we're looking for is about 5%. Anything less than 5% on a normal basis, like, we can change that alpha level if we wanted to, be more strict about it. But on a normal basis, anything less than 5%, is pretty rare. So what we're really saying, guys, is that, look, my sample is so rare compared to the null hypothesis that the null hypothesis can't possibly be true. Because if it were true, I would only see my sample happen 3% of the time, results from my sample, results similar to this sample, I would only see that happen 3% of the time. Whoa, I lost my lights. Let's see if let me stand up. Stand up. Okay, there we go. Sorry, my lights turn out when I'm not moving much, and you'd think I'd be moving a lot more. Hey, anyway, let me finish this off because I'm really done. Because I'm just going to write out what we would say on an AP exam, or would say, because I hope you got the idea of what we're looking at in the p-value. It's the probability that I would see my results similar to what I got in my sample if the null hypothesis were true. Okay, so how do I explain, or how do I write my p-value in the context of this situation? All right, so here's how I would write it. Okay, I would say that there is only a 3.2% chance of seeing sample results, i.e., what was it, 38.5% overweight of 1,000 residents. So there's only a 3.2% chance of seeing these similar results if the actual proportion of overweight residents was equal, apparently I can't spell was equal to 35.7%. All right? So if the null hypothesis were true, I would only see this happen 3.2% of the time. That's rare. That's what the p-value states, okay? So the p-value is a probability. You got to remember that. Remember that the p-value is a probability. It's, in fact, it's the probability of seeing samples like we have if, in fact, the null hypothesis were true. Or simply by chance. Like if I was just going to do this, I only see this happen 3.2% of the time. So that is the p-value. Hopefully that makes sense to you guys. There's not too many times you're going to have to write that out, but there you go. We'll see you next time, guys. Bye.